Hey everyone, I'm Marc Campbell. I'm going to talk about Compatibility Matrix updates and just kind of do a review of what the Compatibility Matrix product is and share some of the newer stuff that we've been building and what we're planning to build. So to start with, if you haven't seen Compatibility Matrix is a feature of the replicated platform that's really designed to create customer representative environments so that you can quickly test a release or debug a customer issue, or do anything that you need when you need a Kubernetes environment to match your customer environment. And just a note here at the bottom, internally, and sometimes in our docs, we refer to Compatibility Matrix as CMX. So if I say CMX, it's a shortcut for Compatibility Matrix. I mentioned customer representative environments. Before digging in, I want to talk about what customer representative environments are. Customer representative environments can be, today, everything from the cloud provider, the Kubernetes distribution, the Kubernetes version, the CNI, CSI, and other add-ons. So basically, what we're saying is you have Kubernetes, and a lot of us think about testing our application on, as Chuck just mentioned, maybe a GitHub action running kind 129, and then you go to the next step and you want to test it on 128, 127. But then all of the different distributions can start to make a little bit of a difference in how Kubernetes acts. OpenShift is a key one that behaves a lot differently. And then there are differences in the CNI and CSI, the networking and the storage interfaces for each of these Kubernetes distributions. So what we want to do is give you really customer representative environments to remove that unknown when you're about to deploy into a customer site. Bringing this graphic back up, Chuck had this on his presentation also. It's this commercial software distribution lifecycle. We talk about the different phases that you actually have to go through in order to distribute your application. And Compatibility Matrix can fit in a couple of different places here. The develop phase, maybe you're a developer and your application doesn't work on OpenShift and you need to build support for OpenShift into your application. Here you can create an OpenShift cluster really quickly, have it last for a few hours, and use it as a remote dev environment to test your application and prepare the code changes that you need to get it to work. For test, which is where we started building Compatibility Matrix, it allows you to create a supported matrix of all of the different distributions and run it in your CI. So you can actually create these clusters in 3-ish minutes, create as many clusters as you need, and then run your end-to-end test to verify that your application works on all of these different distributions. And then the last one is for support. And so if you have a customer who's reporting an issue with your application, you're unable to reproduce it. Maybe you're testing it in GKE, and then you learn from the support bundle in the application that they're running it in a 4 versions old of Azure AKS, and they're having a problem, you can't reproduce it. So we can actually create that customer representative environment and make it easier for you to debug and reproduce that customer issue. How do you use Compatibility Matrix? There's a bunch of different ways. The 2 key ways that I want to talk about are GitHub Actions and our CLI, which can be integrated into any CI workflow. But we also have an API and a web UI, and I'll mention those also. So for GitHub Actions, we publish the link here at the top lists where our GitHub Actions are published. We have a bunch of different actions. I'm going to highlight a couple of them here. Create cluster is a key one here. That's actually how you create that cluster, and it accepts the input of the distribution, the version, and a few other parameters. Then there's COTS install and Helm install at the bottom. These are just easy wrappers so that you can install your application using the Helm CLI or the COTS CLI in an action. The prepare cluster is really similar to create cluster, but it's if you're shipping just a COTS application. Prepare cluster will create the cluster, install the application, and configure the application so that you can just really one action, one step, get the whole cluster up and running with the application. And then there's other ones in the middle, and I'm going to spend a little more time talking about these a little bit later around create Postgres, create object store, and expose port, some of the add-ons that we've actually added recently into Compatibility Matrix. And at the bottom, there's an example workflow from the Slack News application, which shows how we're using all these different actions together to test Slack News in CI. The replicated CLI is another way that you can access it if you're not using GitHub Actions. This is the same replicated CLI that you're using to test your application or using to manage your releases and everything like that today. This has commands to create a cluster, create add-ons, delete cluster, list clusters, get the kube config from your cluster. All of those, they're all there. It's like the same as the GitHub Actions, except portable. It's a single Go binary, so you can put it anywhere you want. The web UI is not probably how you're going to test your application in CI, but it's really useful if you need to create a quick support cluster to reproduce a customer environment. There's a lot of information here. You can manage the quotas that you have. You can see the history of all the different clusters that you've created, and how much each cluster costs. You can create the clusters. And one thing I want to point out here is the CLI has a lot of different flags to create these clusters. And it can get a little bit complicated, a little bit confusing. So at the bottom of the create cluster page in the web UI, it's a really useful onboarding tool and getting familiar with the CLI. You can fill out the form, pick the distribution, the versions, add all the different node groups, add all the different options. And we show the replicated cluster create command right there so that you can use that to start to understand the CLI a little bit more. And of course, all this is backed by an API. Our web UI, our GitHub Actions, and our CLI are all using this publicly documented API. There's no internal API calls that we're using. There's a published Swagger spec here. And if you really want to, you can just hit the API directly and get all the functionality of Compatibility Matrix. And the last thing I want to talk about on the CLI is we frequently show the status of the cluster. And one of the common questions we get are, what are the different statuses? What do they mean? So we tried to normalize this and say every cluster that you create in Compatibility Matrix goes through these steps from queued, assigned, all the way up to running, and then deleted. These are here so that you understand what they mean and what's happening at each step. The running is obviously the one that you have the access to the kube config, and you can actually install your application, run your application, do whatever you need to do. That's when the TTL starts, and the TTL means that your cluster will be deleted after that time expires. The other step right above running that I wanted to spend just a minute talking about is verifying. And it's a step we added in a little while ago. And it's a step that we actually, after the cluster is ready to go, we actually run Sonobuoy conformance tests against the cluster before giving you the kube config in your CI pipeline. And this is a relatively quick, it takes about a minute, excuse me, to run. And it just ensures that like you have a valid cluster, a pod can be scheduled, a pod will start, and then it cleans up after itself. One of the things that we did notice is as you add more and more clusters to a CI pipeline, you do have a chance of getting a flaky cluster or a bad Kubernetes install. And this is for both VMs and cloud services. So we added this verifying step. And if the cluster fails the verification for some reason, we delete the cluster and it goes back to the assign step and it works again to give you a better cluster. Our goal is just to make it so that you're not debugging, is this a failed cluster, failed infrastructure, or is my application tests failing? That's a really terrible place to be when you're in debugging why a CI job failed. So we want to just say we gave you a cluster that at least when we handed it to you, it was running. And hopefully it means that if it's failing for some reason, that's a bug in your code or a bug in your Helm chart or a bug in your application that you can then just know to debug. So Compatibility Matrix creates two different categories of distributions. There's cloud-based managed Kubernetes distributions, including EKS, AKS on Azure, Google GKE, and Oracle OKE. Then we also create VM-based clusters. Of course, we have replicated embedded cluster in curl. We have OpenShift, K3s, Kind, and RKE2. These are the different distributions that we currently support. For the cloud versions, we support as many versions of Kubernetes as the cloud provider currently supports. Oracle being the exception, we've only recently added Oracle support in, so we only have one version. Expect us to roll out additional versions of Oracle Cloud pretty soon. But for AKS and GKE, they only support the most recent 3 versions. For EKS, Amazon keeps extended support for older versions. And so we're able to keep really old versions of EKS up. This matches what any customer can actually be running. So if you have a customer running EKS version 123, you can actually use Compatibility Matrix to create that cluster pretty quickly in CI or to test. For VM-based distributions, we support a lot more. Often here, we support the patch versions of Kubernetes if you want to get to that level of granularity. We have 6 versions of OpenShift that we support from 4.10 to 4.15. And it's definitely worth testing your application on OpenShift. All the other distributions, we support patch versions around everything that's currently Sometimes they're past end of life versions of Kubernetes, but we still support them as long as they're reasonably safe to run, or that you might have customers running that, because we'll see what versions the customers are running. For the replicated distributions, curl embedded cluster, it's any version that you can possibly support today in your application. These are generally release slugs or SHAs that we actually version everything with. You can support those inside CMX. When we talk about customer representative environments, this is more than just the version of Kubernetes in the distribution. It is trying to match what that customer might be running. So if we think about the CNI and the CSI and some common add-ons, for Compatibility Matrix on the cloud managed Kubernetes, we pick the defaults. That is like the best practice, what Amazon, Google, Azure, and Oracle recommend. So for EKS, when you spin up an EKS cluster, you're going to get the AWS VPC CNI, the EBS CSI. This table lists what you get on each of them. Right now, it's not configurable, but you notice that it's not the same. It's not Calico across the board. It's the cloud provider specific CNI that you should test your application with. For the VM-based ones, it's the same. We currently only do host path and local path CSI for those, but the CNI is what, again, is the best practice. And on OpenShift, on 4.15 for OpenShift, they changed to OVN on 4.15. So we actually made that change also. So when you spin up an OpenShift 4.15 cluster, you get a different CNI than you would on 4.14. And that's, again, designed to really give you that customer representative environment. Okay, moving on to some of the newer stuff that we've added. We've added node groups. Compatibility Matrix, I think the last time we gave a talk on Compatibility Matrix, we did support multiple nodes. So you could spin up a cluster, a VM-based cluster, or a cloud cluster with up to like 10 nodes to test your application on. But all those nodes had to be the same. They were just 10 like quantity of 10 of the same nodes. What we've done now is we've added node groups, and a node group is up to 10 nodes that have the same characteristics, the same attributes. And we support multiple node groups in a cluster. For VM clusters, a node group characteristics is really just the CPU, the memory, and the disk size. So it's like the instance type that you actually can configure. For cloud, it's that. So you might be able to specify on AWS like an M6i large instance or whatever. But you can also specify the CPU architecture, whether you want an Intel-based or an ARM-based node, whether it has GPUs or not GPUs, and whether there's auto-scaling enabled for that node group. And you can attach multiple node groups. An example here is, this is a little bit of a more complex example, but it might be what your application needs. And so for EKS, I'm creating an EKS cluster from the CLI on version 129, and I'm adding 3 node groups. The first node group is just a standard 3 nodes of Intel architecture. The middle node group, the G4DN, that's what Amazon calls the Tesla T4 GPU instance types. That's the same. It's 3 nodes with the GPUs and larger disks. And then the bottom one is an auto-scaling node group from 3 to 10 with a minimum size of 5 of ARM-based nodes. And so you can add multiple node groups, like all of the cloud providers support this, and you can add auto-scaling optionally to each of them. The next thing we've added was add-ons. And these are a little bit early in the Compatibility Matrix product. And so the caveat here at the bottom of the slide shows that these are only available today on EKS clusters. The first one that we added is S3, or object store. So once you've created an EKS cluster, you can, from the CLI, any of the ways that you can access Compatibility Matrix, you can add 1 or more S3 buckets to the cluster. And this actually provisions a real S3 bucket, and then it creates a service account. We list the service account name and namespace, and the service account has the IAM role binding in it for both read-only and read-write access to that S3 bucket. So you can then, your application can bind that service account and then access S3. And the nice part about this is you can put whatever data you need to in that S3 bucket. You can use it to test your application, because many applications need S3. And then when you're done, in the cluster, either you delete the cluster or the TTL, the expiration on the cluster expires, the cluster is deleted, the S3 bucket's deleted and cleaned up also. We added Postgres as an add-on, and this is really similar to S3. Again, only available on EKS today, but this allows you to create an RDS Postgres instance. And here you specify the version of Postgres, You specify the instance type and the disk size, and we give you the connection string, the internal Postgres URI. This will create the entire RDS instance for you with Postgres. Obviously, a default database username and password, we put that all into that connection string. And it's deleted when you delete the cluster. This also does things like set up the security group so that your cluster can talk to this Postgres server. It's an empty Postgres database. And so if your application has an option for a customer to bring Postgres, throw this in there as part of your GitHub action or your test, run it with Postgres in the cluster, run it with RDS Postgres, run your schema migrations and test your application in both scenarios. And then the next part I want to spend a few minutes talking about is tunneling or accessing VM-based clusters. We provide these clusters in CI so that you can run end-to-end tests against your application. But in order to do that, you need to be able to access the cluster. And for a cloud-based cluster, it's pretty straightforward. You can actually deploy service-type load balancers. And if you do that in AWS, for example, it creates an ELB, and then with a public DNS name, and you can use that to access your application. And the same is true for AKS, GKE, and OKE. You can actually expose your services to the public internet by deploying a type load balancer. For VM-based clusters, it wasn't that easy. Like these are running on VMs, running on bare metal somewhere. And so how do you actually access them? For a while, we were just recommending using kubectl port forward, which works, but it's a little bit limiting and can be a little bit complicated to set up. So we've added this feature to expose a port. And you can expose one or more ports through HTTP and HTTPS. They have to be node ports that you're exposing. And then what Replicated does is creates a public DNS record and TLS certs for that port. And then you can route traffic through that DNS record into the cluster on that node port through HTTP or HTTPS only. The best practice that we recommend here is, so you can be any node port, but a really good common pattern is to deploy something like the Nginx ingress controller, which defaults to a node port service. And if you do that, then you actually get still path-based routing that you might be wanting to test on your ingress controller. I'm going to kind of some screenshots here of a little demo of how tunnels work. Here, I create a cluster. So I'm creating a simple OpenShift 415 cluster using the CLI command. And then I'm going to kubectl apply just the Nginx ingress controller. There's nothing replicated on the screen here. This is just deploying the default in Nginx ingress controller, which, like I mentioned before, defaults to a node port service. I can verify that that installed by kubectl get ingress class, and you can see now on my OpenShift cluster, I also have the Nginx ingress class. And I'm going to install the same Slacker news application that we were talking about earlier. So I install the Slacker news application with a couple of options to have it create an ingress object. Just with that's really specific to the application, like the values YAML knows how to create that ingress resource. So I do that. I have the application deployed with the ingress resource. And I can actually look and I can see that the ingress Nginx controller node is deployed as a node port service with 2 ports, 80 and 443 internally for HTTP and HTTPS, and those mount to or map to 30761 and 30307. Those are just kind of random port numbers. When you deploy the Nginx ingress service or you deploy node ports, you can actually configure that or have that more static. Then I'm going to run these 2 other commands. So replicated cluster port expose, and that number, the D99, that is the cluster ID of my OpenShift cluster that I've created. And I'm exposing both HTTP and HTTPS on different DNS names. We support all combinations here, so you can have both of those protocols exposed on a single port, or do it this way. And so you can see on both of them, it actually creates 2 DNS records. In the bottom one, that's HTTPS, is modestcray.ingress.replicatedcluster.com. It's a pretty random name that we pick and we assign, but I can now use that DNS name in my browser, in my playwright tests, in whatever it is that I'm running to run a full set of end-to-end tests against my application, because that's a fully provisioned Let's Encrypt cert. And then the cert, the ingress endpoint and everything is the same as the other ones. It's deleted when the cluster is deleted. And the last part I want to talk about is what's coming up in Compatibility Matrix. So we talked about customer representative environments and some of the features that we're adding. We're obviously working to kind of create a little bit more parity. Some of those AKS only features like S3 and RDS or Postgres, we want to bring to all of the other providers, all the other distributions also, because you should be able to test on Google Cloud SQL or Oracle. That's clearly on the roadmap. In addition, we want to be able to expose you choosing the CNI, CSI, and even the CRI that you're actually running the application with. So while today you can, when you spin up an EKS cluster, you're getting the AWS VPC CNI, you might have a customer that you know is running Calico or Flannel or a different CNI inside EKS. We want to be able to support that because there can be problems to discover there around how different protocols are mapped on in the cluster. Often applications need customer supplied infrastructure style dependencies. Maybe you have your application recommend that the customer brings Istio or Linkerd or a service mesh and cert manager and things like this. So instead of having to prepare all those, we want to be able to like bring those with generally customer level configuration already applied. And then it's the same is true for security policies. A lot of enterprise customers running on-prem versions of your application have pretty strict security policies installed in their application, more than OpenShift defaults, but they might be running, OKE with specific policies applied. We want to be able to like have you provision a cluster with a set of known hardened security policies in the cluster. IPv6 clusters, most of these clusters today are IPv4. One exception being Kind clusters on CMX does support dual stack IPv6 and IPv4. And not all Kubernetes distributions support IPv6 clusters, but we do want to be able to provide IPv6 clusters in the matrix if you want to be able to test one or reproduce a customer environment. S3 and Postgres were just the start of these cloud managed services. Obviously, like I mentioned, we want to bring those to other cloud providers, but there's also more. Maybe you need SQS, maybe you need like other services that are running inside those cloud providers. We want to eventually be able to support you just deploying the service broker or creating other cloud services, cloud managed services, and having them accessible inside the clusters. And then more distributions and versions. OKE is our newest one we added. We're always going to be adding in that long tail of Kubernetes distributions that we see out there that enterprise customers might run. That's kind of the Kubernetes side. On the other side here, let's talk about customer representative environments. And this is getting outside of just Kubernetes, but it's things that we see a lot of value and a lot of like discrepancies in, so it's worth testing on. Air-gapped environments. It's really hard to test an application in an air-gapped environment and know that you're not attempting to reach out to the internet. So we want to be able to provide that in Compatibility Matrix pretty soon. Validating with HTTP proxies. So a lot of enterprises might not be running in air-gapped environments, but their servers don't have direct access to the internet. You have to go through a configured SQUID proxy or HTTP proxy. So when creating your cluster, one of the things that we're talking about is being able to spin up these enterprise proxies out of the cluster, next to the cluster, having the cluster configured, and then providing that configuration so that you can test your application respects the proxy variables properly and continues to work in those proxied environments before shipping it to the enterprise. Direct OS level testing and testing on hardened operating systems. I'm going to talk about these two together. When you think about these VM-based clusters, like replicated embedded cluster or K3S, the customer is responsible for bringing the OS in addition to Kubernetes in a lot of these. And it's not always Ubuntu or Debian or RHEL. Right now for these, we're picking the operating system in Compatibility Matrix and then putting OpenShift on it. That there is a lot of security hardened distributions and configurations out there. STIG and CIS are two really common frameworks that are used. We want to be able to provide those hardened operating systems to test the Kubernetes distribution and test your application on. And even to the point where maybe we can just provide that operating system and not put OpenShift or the embedded cluster or anything like that on it so that you can test how your application, you might need just a separate, STIG hardened Rocky Enterprise Linux distribution to put a Go binary on and test or something like that. And so that's definitely something that we're talking about and considering. And then access to other internal systems. You might have a large set of data or models or other internal resources that your application needs in order to really run a suite of end-to-end tests. And when we're running Compatibility Matrix in an environment right now, that can be a little bit difficult. You have to figure out how to do like Tailscale or some VPN in. And so we are looking at ways that we can bridge that a little bit easier and bring those access to those internal systems available to all your Compatibility Matrix clusters. And I think that's it.
Awesome. Yeah, we have a couple comments, but also a couple questions, Mark. The first one's from SJ. If the cluster is recreated when it fails during verifying, will the replicated cluster create command still wait if the wait flag is provided until that replacement cluster is available?
Yeah, it does. We actually wait until it hits to a running state. There's a timeout on that wait flag that we'll respect also, but it does wait until it hits the running state.
Awesome. And Antoine asked, test air gap environments. Will this also take care of provisioning a private container registry with signed certificates?
So yeah, so part of this on the right-hand side of the screen that I still have up right now is that, like, that's a good point. It didn't list down here. I listed proxies and air gap, but it's definitely a common requirement for enterprises to have to bring different registries. It might be Harbor, it might be Artifactory, whatever these are. So we want to be able to provision these alongside your cluster with the credentials, with the certs, with everything, so that you can test your application.
Awesome, great. Other than that, just some feedback on how useful Tunnels has been and some excitement around seeing us thinking about STIG support. So
great. All right, back to you, Grant.
All right, thanks, folks. Let me go ahead and